Antarctica holds most of the ice in the world, 90%, and is highly sensitive to climate change. But getting a complete picture of the melt that's happening isn't easy.
It's interesting how you measure the loss of ice, because ice melts off the top of the ice, but as that ice melts, obviously it loses some of its weight. So the weight of ice pressing down on the rock underneath becomes less. So actually the bedrock underneath Antarctica, the bedrock underneath Greenland, begins to bounce up. So in other words, simply measuring the height of the ice doesn't actually give you a measurement of whether any ice has actually melted off. The way they do it is they send round satellites, and the satellites actually measure the gravitational pull of the massive ice underneath it. And over the years, the gravitational pull of the ice of Greenland has become less. And you can measure the change in gravitational pull, and that gives you a better idea of how much ice you've actually lost. Because the amount of bedrock stays the same, but the amount of ice gets less. Therefore, the gravitational pull as you go over Greenland or as you go over the Antarctic actually changes over the years, and that gives us a good idea of how much ice is being lost.
One part of the Antarctic in particular is under scrutiny, the Thwaites Glacier. Thwaites sits over the western plate of the Antarctic. It's also known as the Doomsday Glacier. If it melts, it could set off a chain reaction that will cause sea levels to rise many meters worldwide and devastate low-lying areas.
The Thwaites is a very important glacier because it represents, so to speak, the melting of one particular part of the Antarctic. This is the Antarctic. This is the Antarctic with all the ice covering it. But were all the ice in Antarctica to melt, it would look very, very different. All the blue areas are areas below sea level. So what we'd be left with, we would see the Transantarctic Mountains curling across. We'd see some mountains around here. The Thwaites is running in here, but look at how much is below sea level. So all the ice over this area would disappear. It's been called the Doomsday Glacier because if we study that, we get an idea of what might happen in the rest of Antarctica. So when we see the Thwaites speeding up, emptying more into this part of the Antarctic Ocean, then it's a big thing to be worried about. You may think of ice as a solid, but it behaves like a liquid. It flows with gravity down towards the sea. And by putting sensitive GPS instruments into the ice, powering them by solar panels above, you can tell how fast the glacier is moving over the course of a winter, a summer, over the course of several years. And that's what scientists have been doing on the Thwaites. They've been measuring the rate of flow of the glacier. And the Thwaites now is moving much faster than it used to be. And that's an indication of how much the Antarctic is warming up. And Antarctica warming up is really crucial for the rest of the world, because the volume of ice that is locked up in Antarctica, which at the moment is out of the sea, if that ice begins to melt and flow towards the coast and go into the sea, then just like adding water to your bathtub, the level of sea will rise. Then suddenly you're beginning to flood parts of the world which had been previously dry. And when we think about how much of the Earth's coastal area, where think how many major cities there are in places like that, London, New York, Miami, large parts of Bangladesh, for example, even some small island states in the Pacific, those are all going to be under threat from climate change. And one of the big sources of that extra water is going to be water flowing in from the melting glaciers of the Antarctic.
Scientists working at Thwaites have also been in the news recently for drilling through hundreds of meters of ice. And it's not always obvious why that's necessary.
What they've been looking into with Thwaites is they want to know what's happening on the edge of the continent, what is happening underneath these ice shelves. When the air temperature warms, obviously the ice melts off the top of a glacier, but when the sea warms up, it's also maybe that the ice is melting on the bottom of the glacier as well, because some of these glaciers, remember, they come down, they flow across the rocks, and when they hit the sea, they go out to sea and they're floating for hundreds of miles out to sea. And if that sea heats up, then the ice is actually thinning from the underside as well as the top side. So what they're interested in, the Thwaites, was they're actually drilling through the ice close to where the glacier meets the sea, drilling all the way down through 400 metres of ice down there so that they could measure the temperature of the sea immediately underneath the glacier, and also put down cameras and see what was happening underneath. And what they have found is that the sea underneath these glaciers is warmer than they thought it was, and therefore they can make an estimate of how much the glacier is melting from the bottom. And the fact is that some of the Thwaites, as I say, is not connected to the land. It's floating on top of the sea. And all this is bad news, because all this will thin the Thwaites and likely to increase the flow of ice from the centre of West Antarctica towards the edge. If you had asked scientists 20 years ago, is this possibly going to happen? They might say maybe, but it won't be for 100, 150 years. But now the changes are happening much more quickly than they ever anticipated. And it is a real emergency, a real climate emergency, to get a handle on the changing climate so that we can slow down the disappearance of ice from the Antarctic.